Hello everyone. So let's talk about today's Geeks for Geeks problem of the day. So what is given in a problem statement? Let's see, and after that, let's try to understand what we have to do. So you have given a root of the binary tree. Okay, so you have given a binary tree. Your task is to return the left view of the binary tree. The left view of the binary tree is set of a nodes visible when the tree viewed from the left side. If the tree is empty, return the empty list. Okay, so just we have to return the left view of the binary tree. What is the meaning of if you are looking from this side, the node which see first which you have to return. For this example, the answer is 1, 2 and 4. Okay, so let's see what is the another. So suppose this is the another example. If you try to see from the left side, so you will see only three nodes, which is 1, 2 and 3. For this, answer is a 1, 2, 3. Now this is the another tree. So if you see this from the left side, so what is the first you look 1, 2 and 4. Okay, so this is the answer for the third test case. So you have to just return this output. Now how you will try to do this? So if you look the tree, observe, so what you are doing, you are just traveling from the level by level. Just try which node come first. If this node is coming first, that means the node is coming first, you just put it into a map or the answer or the array list. So what is the first intuition come in your mind? Okay, so the approach one is a simple level order traversal with some conditions. Okay, the approach one is simple level order traversal with some condition. Okay, now let's see how we will code this approach one. So before coding, let's try to understand how we'll just solve this problem. Okay, now this is the tree. This is a small tree like 1, 2 and 3, and what is the answer for this? The answer is a 1 and 2. Okay, so now you are, how you try go, you just push this node into your queue. So you just queue dot push root node, and after that you just try to iterate on that queue. Okay, so this we basically do in a level order traversal. After that you just write a while is not equal to empty. Okay, and after that you just do the for loop for I is equal to 0 and I is less than n and I plus plus. Okay, similar something like that. So what I am saying, before starting or iterating on this loop, we can put, if the what we can do, we push the queued front data in our array list, and we simply, what we do, we simply return that array answer. The array answer, why I'm doing in the first place, because whenever the new level is coming after that for loop, if this for loop iterating one, and it will, after that for loop you just come with the new level. So when you come the new level, you just have the all the elements. Suppose in a first level the queue will contain the 1, in a second level it will contain 2 and 3. So what you have to do, you have to just, you have to just print the front element. Now after that, suppose there is a some node like 3, 4, 5 and 6. So what is come, the 3, 5, 3, 4, 5, 6, 3, 4, 5 and 6. Okay, so you just add the 3 into your queue. So let's try to code it out. This is very simple and very easy approach, so I don't think so we have to try run, because this is completely on a level order traversal. So if you know the level order traversal, you can easily solve this problem. So what I'm saying, queue, okay, node star and queue. Okay, now I just push the node q dot root. Okay, and after that I'll just define the answer vector in answer. Okay, now while q is not empty, okay, until the q is not empty, you have to just return. Okay, so what I'm saying, just push that answer dot push back q dot front data, q dot front data. Okay, and after that, just write a for loop is starting from this n and I plus plus. Okay, now what is the n? N is the size of the queue. Okay, so integer n is equal to q dot size. Or I am just writing a simple and standard uh, level order traversal code. So this is nothing new. So what I'm doing, just take a front node and just see. I'm just pop that at this node as well. Q dot pop. Okay. If f dot left, then just push f left. F dot right, just push f dot right as well. Okay, now what you have to do, you have to just return that answer. Okay, let's try to compile it and submit it. Okay, if it is get compiled successfully, let's try to submit it as well. So okay, so it passes this example test cases. And what is the first thing I just see, that we just left with the one condition. If the root is a null, means there is no root present, just simply return the empty list. Okay, so this is the edge case we left with. Okay, now again I just compile it, and if it is get compiled successfully, just try to retest. Okay, now yeah, it passes this test cases, so try to submit it. Okay, so yeah, it get accepted. Now what is the second approach I'm saying? If we can do this in a BFS, can we do it in a DFS? So let's try to figure it out as well. So let's see with the DFS. So approach 2 is a DFS. So suppose I have a tree with the values 1, 2, 3, and a 4. Ignore the handwriting. Okay, now what I'm saying, uh, I have to just go. I'm doing in a level. I'm just going level by level, and I'm trying to insert the value of that level. Insert the value of that level in where? In my answer array. Okay, in my answer array. So can I say I can do the DFS as well on each level? What I have to take? Suppose this is my pre-order call. Okay, suppose I am doing a pre-order traversal. Now this is my root node, and for each level I will take a level value. Okay, now the level initially on a first, then level second, and level third. So what I'll do, I'll just increase for the root left. I will increase level plus 1. Okay, and for the right I will increase the level plus 2. But what happened for this node, the level, sorry, level plus 1. Okay, here also level plus 1, my bad. So level plus 1. Okay, and this is the pre-order traversal. So if I am just writing the PO. Okay, so this is the simple call for the pre-order traversal. So pre-order for PO. Okay, so root and level. So what I am saying for this level the value is a 1. For this call, for this node, level value is a 1, and this node for the level value is 1. So if I just keep that level value same, so what will happen? So it will print twice, means it will push the value in my array 2 times, like 2 and 3. So it will not achieve our answer. So what I'm saying, if the level is coming first time, so I will use a set or a map to mark if that level is coming first time. If it is coming first time, what you just do, just insert that into a map and then insert the value in that level. So what I am saying, let's see. So I'm using set here, an ordered set. So for example, that set contains a 0 value. So what I'll do, I'll just call for the 1, and I will just check if that set dot find, okay, that level is not equal to set equal to set dot, so level for L n. Okay, if this condition is satisfying, just push that level, push that value, that root value into answer. Okay, push the root dot data. Okay, now let's see with a dry run example, and you will understand clearly what I am saying. So the level is first, so I am coming here. This is my answer vector. So I come here. This condition is satisfied. So what I will do, I'll just go and I'll just push that one into my array. Okay, now again I'll just call for the left. For the left, I'll just increasing the level by 1. So my level will become 1 here, and I will, after that I'll just see that level is coming first time. Yes, it is coming the first time. First level is coming first time. So what just do, here is a set. So I mark that. Okay, here is the level 2, here is the level 1. So I will mark 1 in a map. So, and I'll check the 2 is present in the map. No, it's not present. So put into a map or a set, or just insert that value in my answer array. Now I'll go for the left. I'll just check the level is 3. So I will check that level is present in a map set or not. If it is present, then just try to mark it out true, or if it is present, just ignore it. If it is not present, just try to mark out. So let's mark it and just add the value in answer. Okay, now again it will go to the back, it will go to the back, and it will go to the right side. Okay, if it is right side, what is the level here? Level is 2. Now I just check the level 2 is present in a set. Yes, it is present in a set. So ignore this level and just go for the next one. So the next is a null. So answer for this is the 4. So let's try to understand and let's try to code it up. Okay. So what I am saying, I'll just take that this condition is satisfying. So I'll keep that answer as it is and I'll just solve this answer. Okay. So return the answer and this where to make a solve. Okay. Solve. What I'm doing root and then level. Level is starting from the one and the answer and the set. Okay. So I'll just take a set as an SS. Set of integer or node star. Okay. I'll just take integer SS. Okay. And the answer is correct. Okay. So let's try to solve it. Void solve node star root then integer level and then integer vector and answer. Okay, now vector int answer and set int ss. Okay, now what I just do, if not equal to root then return. Okay, if ss dot find that level is equal to ss dot end, what you have to do, just answer dot push back root the data and just go for the next and right column. That's the common thing. So what I'll do, I'll just mark ss dot insert that level. Okay, yeah. So this is for now. What I'm just doing, I'm just writing a standard pre-order code. So this is the root left, then level plus one answer and ss. Okay, and for that root right. Okay, now so it will push all the values. So let's try to compile it, and if it is get compiled successfully, let's try to submit it and let's discuss its time complexity and space complexity. Okay, so yeah, it get compiled successfully. So let's try to submit it. Okay, so yeah, it get accepted successfully. So let's try to optimize it. What is the time complexity for this? The time complexity for this is like see, this recursion call is going to the big of n time. Okay, inside that big of n time we are doing the log n operation. You can use unordered map here. So this is n log n. So if you are using the unordered map, it will take a big of one time. Now it also takes the big of n time. Okay, and so what is the space we are taking? We are taking the set for the extra big of n space and for the answer extra big of n. So space we are taking with the big of n plus n. Space complexity is taking we have big of n plus n. Okay, and time complexity we are taking big of n because we are going to the all node into log n. Log n, why? I'm just inserting all the values, so that's why I'm taking the log n and checking for this value. So we can use this with the unordered map. It will get to 1. So overall time complexity is big of 1 if you are using just unordered set. So and previous time complexity is big of n and we are taking extra space for the key. So the both are same, but it has some recursive space as well, recursive stack as well. So it is a slow as compared to the iterative approach. But can we optimize it in further way? So let's see what we are doing actually. So for each level we are keeping track for the value which are visited, the level which are visited or not. So instead of doing this, what I am saying, I will just say if this is a 2, so what is my previous level? That is the 1. Okay, if this is the level 3, what is my previous level? 2. So I will take a one variable which is mark a maximum level till I visited. Okay, because in a level order traversal we just go here. So the maximum level is a 3 and again I am coming here. So what is this 2? But I visited already 3. So my max level I visited which is 3. So if I am visiting 2 this time, it is not new node. Why? Because I already visit till 3 and each time I'm visiting I am going to the left to right. So left, if I am going left to right, so this level, these values are coming first. Suppose the tree like this, suppose this is the tree, so suppose this is a level, so I visit this level and a pre-order travels first, then this level and a second. Okay, after that I just go here, so this is a second level and then I go here. So what is this level? 3. But in a pre-order, when I'm doing the first time, it is only visited maximum level as a 2 and this is third level is coming from the right side. Okay, so the and my visited maximum level is a 2. So if the value of the new level, if the level value is greater than the max visited level, okay, max visited level, then that level is coming at a first time. Okay, so I can push this data as well. So instead of using map, I will keep track of a one level variable. So instead of this, I'll just take an level max level. Okay, and as an I'll just define is a max level. Okay, I will pass it as a reference. Okay, instead of set, I'll just pass this as a reference. So I'll just small it out. Okay, so let's see, integer max level. Okay, now what I'll do, I'll just max level, I'll pass here max level, and here as well max level. Okay, now what I will do if the level is greater than the max level. Okay, if this condition is satisfied, that means the level is coming first, so you have to update that max level as well. Okay, is equal to level, and just insert that data into your answer. So let's try to compile it and try to submit it as well. So this is the one optimization we do in a space complexity. The time complexity is still big of n, but if you are taking, we are not taking any extra space, we have just going with the recursive stack space. Okay, so what is the answer? The solve. Okay, so the solve root one answer and max level. Solve root. Okay, what is the expected is semicolon. Okay, here. So max level is equal to first. So 0. Okay, the first level is also coming the first time. So the max level is 0. Let's see. Okay, yeah, it's compiled successfully. Let's try to submit it out. Yeah, it get accepted as well. Okay, so what I'm doing here, I'm just saying the maximum level. So instead of using map, I'm just using the max level. Now let's see what is the uniqueness coming from this side. So suppose I have a tree, 1 2 3 4 and 5. Suppose this is a tree, and suppose this is also a tree. Okay, nice. So this is a tree which is given to you. So I will visit this level first time. So my maximum level is a 0. So if I visit the first level first time, this is coming first by because I already visited only 0 level. So this is the first node I'm going. So I will insert into a map. Okay, and what I'll do, I'll just update that max level, so it will become a 1. Now this is my second level, and the maximum level I visited is a first. So this is coming in my first time, so I will just insert this and I will update the level. Okay, now this is my third level and I am coming it on a first time. So what I will do, I'll just insert this here and I'll just update the max. Now here is no node, then it will go to right, it will null, so it is a null. Then after that it come here. So what is this level 2? But my maximum level is 3. So what is the meaning? When I am doing a pre-order traversal on a left side, I already go till the third level. Okay, so the level is coming on a right side, it's already visited from the left side. Okay, now here I go, here is the third level. Now if here is come, here is the fourth level, but my maximum level is a 3. So can I say the level on the left side is already ended and I have a left node on the right tree? Okay, so this level is not visited, so I will just push it out in my map and it will get accepted. What is the time complexity here? So time complexity is big of n. Why? Because I am traveling the all the nodes of the tree and representing the node values, the value of a node. And what is the space complexity? Space complexity is the big of h, which is the height of the tree. Why? Because I'm going to depth of the tree and it is a recursion. So in a recursion we are using the recursion stack. So the what is the maximum level? It will go to the stack 1, then 3, then 4, and then 5. Okay, so this is my stack end. Okay. Suppose like we this one function, then 3, then 4, and then 5. So this is my maximum height of the stack. So this is the big of h, the height of the tree, the maximum height of the tree. So the space complexity of big of h. If the interviewers say you can neglect the space complexity of the recursive stack, so this is the space complexity of big of 1. Okay, and the time complexity of big of n. So this is some optimized approach. So this is for today. Let's meet tomorrow with a new video. So if you have any doubt in this question, let's try to discuss in a comment section. This is very important interview question. So to revisit all the approaches one by one. So thanks for today.